Okay, here we are, VCAA 2021 Specialist Maths Exam 2, Section B, Question 3. And so here we're, thin-walled vessel is produced by rotating the graph of y equals x cubed minus 8 about the y-axis between 0 and h. So what we're going to have to do is set up in part 1, we're going to have to set up an integral. Now, because we're rotating around the y-axis, we need our equation in terms of x equals. So when we do that, then cubed root, and then of course we need it in index form. So y plus 8 to the 1/3. All right, so then we've got to write down our integral in terms of y and h for our volume. So our volume is pi times the integral from 0 to h. That's where we're going. Y plus 8 to the 1/3 squared dy is what we're after. And now we can neaten that up a little bit, and we can say that it's 0 to h of y plus 8 to the 2/3 dy. All right, so that's all you're asked to do. Write down the integral. You're not asked to, at this point, solve it. However, in the second one, we then need to find an expression. So now we need to solve it. So what we need to do here then is go to our calculator and have a look and see. So we need to do the integral. Whoops. Need to put the pi at the front, of course. Then the integral from 0 to h, and I'm going to use z instead of h, of what? Well, my integral is y plus 8 to the power of, and so I can just click on the power of, use the 2/3 dy, and there it is. So that's not in a real super nice handy way, because we've got a 5 that can come out and go with the pi, and we've also got 3 goes in there, and 3 does go into 96 32 times. So in the end, what we can say is that our volume is 3 pi on 5, h plus 8 to the 5/3 minus 32. All right, so there we are with that. All right, next part of this question says, water is poured into the vessel, however, due to crack in the base, it leaks out at a rate proportional to the depth of the water, and here it is, minus 4 root h, where volume is the water in the remaining vessel after t minutes. All right, so show that dh dt. Now, a show question. Show questions require working out, so you need to show working out. Now, this is dh dt. We've got dv dt there. All right, so how are we going to connect that? This is like related rates. So you can actually say that dh dt would be dh dv times dv dt, and we have dv dt here, and dh dv, well, we've got an expression for the volume, and so what we can do is use that expression for the volume, which we have up here, All right, we've got our expression for the volume. And so if we differentiate that volume, well, we integrated this one to get to there, so we're going back to this here, the pi and the y plus 8 to the 2/3. And in this particular part of the question, we're using little h as our y. So from that, we know that dv dh then is h plus 8 to the 2/3 times pi. And we need dh dv, so dh dv, if we just flip 1 over, so 1 over pi times h plus 8 to the 2/3, and so the h dt will be 1 over that, h plus 8 to the 2/3, times dv dt, which we were told is negative 4 root h. And so when we put those things together, we get negative 4 root h over pi times h plus 8 to the 2/3. And so therefore we've now shown what we need to show. All right, next question, or part of the question. Find the maximum rate. So maximum rate, so that's when the rate is a maximum. All right, we'll get to that in a minute. Which the depth of water decreases. So we're being told it's decreasing. Correct 2 decimal places. Okay, we'll get to that at the end. And find the corresponding depth. Okay. So let's, initially it talks about the maximum rate. Well, we know what the rate is. Here's our rate. Here. All right. And so we want to know when that is all right. So h is our depth. Sorry, h is our depth with time. So this is the rate that the depth is changing. All right. So what we actually need to actually know here is when this is at a maximum and decreasing. So that's where this negative comes in, the decreasing. So we're looking at where that particular thing there is a maximum. So in terms of what we might want to work with, what we're really looking at is when the second derivative is equal to 0. All right. And the second derivative, because this is in terms of h, what we're going to do is we're going to again use the chain rule here and separate it and say, well, what we're actually wanting to do is take our dh dt and we need to differentiate that with respect to h. But because we want t squared, well, we need dh dt as well. And dh dt we know that because there it is there. So that derivative, all right. And what we know, what we need to find out is when that's equal to 0, we don't need to know what h is. All right, and so when you do that on your calculator, In the interests of time, I'm not going to do that. So you differentiate that with respect to h, you times it by this stuff here. You then set up an equation where you solve to equal 0 for h, and you find that h is 24. So we know that the maximum rate of decrease in this case occurs when h is 24. So what we need to do is dh dt by putting 24 in there. So negative 4 root 24 over pi times 24 plus 8 to the 2/3. And when you do that, you get negative 0.6188. All right. Now, the question, let's go to the question. It says the maximum rate which the water decreases. See, they're telling you that the water's decreasing. Now, that's what this negative indicates. And so what we need to say then is the max rate of decrease to 2 decimal places is equal to 0.62 centimetres per minute, and at a depth, because they're asked for the corresponding depth, of 24 centimetres. All right, so need your calculator there to work out this stuff. All right, the next thing it says, let h equal 50 for a particular vessel. The vessel is initially full. Water continues to leak out at this rate of 4 root h centimetres cubed per minute. Find the maximum rate water can be added to the vessel without overflowing. All right, so if h is 50 and it's initially full, we've got to keep this h at 50. Now, the water is leaking out at 4 root 50 on this, which is 20 root 2. All right, centimetres cubed per minute. That's what the water's going out. Now, we want to put water in, but we don't want the vessel to overflow, but we want to keep it full. So if it's leaking out at that, then we've got to, therefore, can fill at 2 root 20, or 20 root 2, I should say, at 20 root 2, cubic centimetres, not metres, cubic centimetres per minute. And then inflow and outflow will equal each other, and it would remain at the same level, which is full. All right, there is a last part to this question, part C. Vessel when initially full, where h is 50, the water leaks out at that 4 root 8. When the depth of water drops to 25, more is put in. How long does it take to refill? All right, how long is time? And refill, get the water depth back up to 50. If you answer in minutes correct to 1 decimal places. All right, so what do we know? How is the volume changing? dV/dt. The volume is changing in the following way. So it's going out at 4 root h, which is, and h is 50. But extra water is being poured in. So I'm going to just work from the 25, all right? So water's coming in at 40 root 2, but it's still leaking out at negative 4 root h. All right, so that's when it gets to that depth, that 25, and now we're putting it in and we want it to fill. All right, and we'll get to that in a minute. All right, so and dVdh, we've already had that from before, and we used that before, h plus 8 to the 2/3, and there we are. All right, so dh dt, that's all what connects these things together, volume, height, time. So dh dt is dh dv times dv dt. All right, and so we've got those two things. Well, we have when we flip that one over, that's all right, and we've got this dv dt. So when we flip that one over, then that comes underneath, and so what we end up with is 40 root 2 minus 4 root h over the pi h plus 8 to the 2/3. All right, so that's how the height of the thing is changing. All right, so the time to fill. So the time to fill comes about then when our height, so we were looking at our height to go from, because it's at 25, and we want it to go to 50. So we've got to set up an equation. So we've got to do a separation of these things. So if I move that stuff over there, and to do that I've got to flip it. So it becomes pi h plus 8 to the 2/3 over the 40 root 2 minus 4 root h. And the dh stays there. Integral of this stuff. And then that's the integral of 1 dt. And so that then just becomes the time that we're looking at. And the time that we're looking at is when the depth goes from 25 to 50 of this particular pi h plus 8 to the 2/3 over 40 root 2 minus 4 root h dh. That then, of course, is a calculated job, and when you do that, you find that the time comes out to 31.4307. We're asked, just poking here, correct to 1 decimal place. So correct to 1 decimal place is 31.4 minutes. All right, so there is that particular question.